Hello, welcome to Quadratic Functions Guided Notes with Alan Batch and Jacob Saylor. Today we'll be discussing all it is that we need to know about quadratic functions in our standards. So let's get to it. So, what is a function? Functions is a relation between a set of inputs and a set of permissible outputs with the property that each input is related to exactly one output. So, for example, if we have an equation f of x equals x plus 1. So if x will equal 1, then you just put that in its place and it would just be simply 1 plus 1, and that just equals 2. Graphing linear and quadratic functions and showing maxima and minima and intercepts. Maxima is the height of the function at a is greater than or equal to the height anywhere else in the interval, whereas minima is the height of the function at a is less than or equal to the height anywhere else in that interval. So if we look right here at this, you will see that the highest point is the maxima and the lowest point is the minima, just like it says. And for intercepts, the x-intercept of a line is the point at which the line crosses the x-axis. So right here is an x-intercept. And if you look back in the definition, it says whereas the y value will equal 0. So y, the value will equal 0. So here's 0, y, yeah, it's going to equal 0. Now y-intercept of a line is the point at which the line crosses the y-axis. So here's the line, it's going to cross the y-axis, and it says right here where the x value equals 0. So the x value will equal 0. So let's do some graphing. So if we have the equation y equals x squared minus x minus 2, all we have to do is get out our calculators and go to the table key and plug this in to the equation. You guys a second to do that. Okay. Now after you plug that in, you get these numbers. You get -2, 4, -1, 0, 0, -2, 1, -2, 2, 0, and 3, 4. So if we graph this, let me get my pen out. So -2, 4, -1, 0, 0, -2, 1, -2, 2, 0, and last but not least, 3, 4. So after we get that, excuse my drawing, we can graph this. So as we see, these are our zeros, -1, 0, and 2, 0. So the y's will equal 0, so these are our x-intercepts. And this point right here is going to be our minimum. So the next problem. F of x equals 3x. So I'm going to have you guys pause and type that into your calculator in the table key and see what you guys get. So when you enter those points in, you get 0, 0, 1, 3, 2, 6, and last 3, 9. So let's plot those points in. 0, 0, 1, 3. Oh, and I forgot to mention, this is going to be a linear function because it does not have a square. 2, 6, and 3, 9. So let's graph that. Straight line. My drawing. And we have our y-intercept at 0, 0. This is a minimum, and this will be a maximum. So, next standard, MCC 9-12.f.if.a. Factoring completing the square to show zeros of a function, extreme values to make sure out. So, we just showed the zeros of a function by graphing. So now we're going to do it by algebraically solving it out. So, when a equals 1, factoring is fairly easy. The equation can be factored into a form y equals x plus p x plus q, which are your factors p and q, where p and q equals b and c, p q equals c. For example, if given the equation y equals x squared minus 9x plus 18, we need p and q values such that p plus q equals negative 9 and pq equals 18. A quick check will tell us that p equals negative 3 and q equals negative 6 are values that make sense. So our factored equation is negative x minus 3, x minus 6. So since y equals 0 for x-intercepts, we can set the factored form of our equation to equal 0, which we can use to find zeros of the function. The entire equation will be 0 whether either or both of the fractions are 0. We can find the roots by solving each factor for x. The factors x minus 3 equals 0 and x minus 6 equals 0. Meant that our x-intercepts are 3 and 6. So here's an example. f of x equals x squared plus 5x plus 6. So we need a factor to find the zeros. So here's our problem. Now let's factor. What can we What two numbers can we use that add up to this one and then but multiply in this one? Easy. 3 and 2 add to 5 and they also multiply by 6. So after we did that, it takes these two, x plus 3 equals to 0, like I said in the last slide. X plus 2 equals 0. Make each of them equal to 0. Now we just do basic algebra. Get x by itself, so we subtract 3 from both sides, and then we subtract 2 from both sides, and then we get x minus 3, and then x minus 2, and our zeros are negative 3 and negative 2. So, completing the square is another way to factor, starting with the standard form of the equation y equals ax squared plus bax plus c. We can use the following steps to create a perfect square trinomial and solve for the x-intercepts that way. So step 1, set y equals to 0. Number 2, divide through by a. The coefficient in front of x squared must be 1. So y equals x squared plus ba is that a fraction, x plus ca is a fraction equals 0. Step 3, subtract the constant factor from both sides. X squared plus ba, x equals negative ca. Now, number 4, we write the function in the form x squared plus 2hx plus h squared. So ba equals 2h equals h equals b 2a, and then this is another form. X squared plus ba, x plus 2. Next. So, and then step 5, we write the function in the form x plus h squared. X plus b 2a squared equals b squared minus 4ac 4a2 squared. And then number 6, step 6, take the square root of both sides. So the x equals negative b plus or minus the square root of b squared minus 4ac over 2a. It turns out that completing the square is a straightforward way to derive the quadratic equation. We can also describe extreme values from up here and of the function or the vertex of the parabola if we return to the original form of the equation y equals ax squared plus bx plus c. Coordinates of the vertex can be written as parentheses negative b over 2a comma negative b squared minus 4ac over 4a. So here are some examples for completing the square. X squared minus 6x plus 8 equals 0. Then we make a space right here, divide this by 2, and then you gotta square that, and then that would just be plus 9 plus 9, and then you gotta factor. So after we factored that, just simplify it, and it would just be the same, x minus 3 squared, which is the same thing as this one. And then you square root both sides. And then when you square root both sides, you're going to get x minus 3 equals plus or minus 1. So that would just equal x minus 3 equals 1, and x minus 3 equals negative 1. So if we get x by itself plus 3, get zeros, will be x equals 4, and x plus 2. Alright, our new standard, MCC9-12.F.I.F.9. Compare properties of two functions, each represented in a different way. Information can be presented in many ways in math. They can be presented algebraically, graphically, numerically in tables, or even by verbal description. In this standard, we will focus on how we can do this by focusing on quadratic functions, comparing them with linear exponential functions, and studying in the coordinate algebra. So suppose James and Timothy threw a ball in the air. The height of a James ball is measured in height times negative 16t squared plus 79t plus 6, where h is in feet and t is in time, of the height of Timmy's baseball is given below. So James claims that his baseball went higher than Timothy's, and Andre says that his baseball went higher. So who was right? How long is the baseball air for? So, so a portion of the graph of a quadratic function f of x is shown in the xy plane. Selected values of a linear function g's of x are shown in the table below as x dx. The coordinates. As an example. And next standard. Combine standard functions types using arithmetic operations. In this standard, we will determine an explicit expression, a recursive process, or steps for calculation context. We will focus on quadratic functions and compare them with linear exponential functions studied in the coordinate algebra. If and find f of x equals x4, g of x equals 3x minus 5, f plus gx. So, here's another example that you can do. Anne is shopping and finds a $30 sweater on sale for 20% off. When she buys a sweater, she must also pay 6% sales tax. Write an expression for the final price of the sweater in which way that the original price is still evident. Attention, if the clerk just adds 14%, will the price be correct? And last standard. Combine standard functions types using arithmetic operations. In this standard, we will combine standard function types using arithmetic operations while focusing on quadratic functions and comparing them with linear and exponential functions studied in coordinate algebra. You have a 2-foot step that needs a wheelchair ramp in order to comply with federal regulations. Building code states that a wheelchair ramp angle can be no greater than 0. You have several boards in storage. If you have a board of length L, determine the angle it will make. Another example.